Welcome. In this video I'm going to show you how you can determine the variation ratio using RStudio, and this is going to be about the variation ratio as defined in the APA Dictionary of Statistics and Research Methods, where they define it as the proportion of cases that deviate from the mode. So that's not the same as the variation coefficient, so that's something else, and there's also sometimes I think a variance ratio, so that's also something else. This is about the proportion of cases that deviate from the mode. To run this command first, Control Enter, to show you that I only have installed some basic packages by now, and I won't be needing any other package except to load my data. The data that I'll be using is actually coming from an SPSS file, and that actually requires a foreign library, and I already installed that package. I'm not going to run that line above. So now my library is installed, and now let's run all of this so I actually get some data in. Then the first thing I want to do is show you how you can determine a variation ratio using for a Unimodal dataset. That's going to be stored in my table, and that's going to be a table of my data and then the Unimodal. To show you the data, I have some data that will be Unimodal, so there's only one mode. Here there are actually two. Here there's none. And I have the same for the scale variables, but in this case that doesn't really change anything, so I won't be using those. Let's run this my table line. Control Enter. And actually it's always good to first inspect the result. And as you can see, brand A was chosen twice, B 4 times, C twice, D only once, and E also only once, so brand B is actually the mode. So the variation ratio is simply then the proportion that is not belonging to the mode. The mode is in this case the maximum of the frequencies, and we can divide that by the sum of all the frequencies, so that will give us the proportion that is actually the mode. And then we do 1 minus that proportion, and we have our variation ratio. Control Enter. And in this case that turns out to be 0.6 or 60%. There's no fixed rule on to say if that's a lot or not, but I think this is quite a lot, so 60% of the scores are actually not from brand B, so there's quite some variation going on. If you have more than one mode, it's a little bit trickier, so let's do another table, same result but now using the bimodal variable. And let's go for my table 2, and as you can see brand A is here chosen 3 times and brand D as well, and that's both the maximum, so they're actually 2 times the mode. So in that case what we could do is, because I didn't find any references to how to actually deal with this, so my assumption would be because both are the mode, I would need to know the maximum frequency, which is going to be that 3, and as you can see here it's actually indeed 3, and I need to know how often that occurs, so that's going to be the sum of that second table if it's equal to the maximum frequency, and that should be 2 in this case, as you can see up here. And then I can determine the variation ratio because we have twice that 3, so I do max count times the maximum frequency, then divide by the sum, and do then 1 minus that result. So in this case the variation ratio is 0.4, which is already a lot less. So 40% of the scores are not brand A or D. And that's how you can actually determine the variation ratio using R or RStudio. In case there is no mode at all, you might want to say that then the variation ratio is 100% because everything varies to some extent. And again, there's not much written about how to deal with the variation ratio in these cases, so it's a little bit up to your own interpretation there. If you do find a reference that deals with this, please let me know. If you enjoyed this video and found it helpful, please subscribe because that really helps out. I'll stop asking for that once I hit the 1,000 subscribers. And thank you for watching.